You're having a normal day when you walk into the kitchen and realize a heinous crime has been committed. Someone has stolen all of the treats off the kitchen counter. You see a tuft of hair inside the container and decide to DNA test it because that's what any rational person would do, right? You have 4 pets, so 4 suspects. Then there's the victim, that's you. By using DNA fingerprinting, you're going to compare all of the suspects and the victims' DNA to see not only who stole the dog treats, but while you're at it, why not see who is related? So we have 2 different loci here that we're going to be looking at, all from the same tuft of hair. Let's take a look at locus 1. So looking at the first allele, we can see that both suspect 1 and 3 have that same allele. Looking at the second allele, both suspect 1, 3, and 4 all have that same allele. This rules you out, the victim, as you shared no alleles with the evidence in locus 1. It also rules out suspect 2 and 4. However, we cannot rule out suspect 1 or suspect 3 because they both match with the locus 1 in the evidence. Now let's move on to locus 2. The first allele matches suspect 1 and 2. The second allele also matches suspect 1 and 2, but also suspect 3. This rules you out, the victim, as you shared no alleles with locus 2, and suspect 4 as they showed no alleles with locus 2, but also rules out suspect 3 because they only shared one allele with locus 2. Suspects 1 and 2 both matched both alleles for locus 2. Looking at both loci, let's see if we can determine whose hair was at the crime scene. The victim didn't match any loci on the first or second locus. Suspect 1 matched with both allele on both loci, so we cannot rule them out. Suspect 2 didn't match any alleles in locus 1, but they matched both on locus 2. But since they didn't match both loci, we can rule them out. Suspect 3 matched both alleles in locus 1, but only matched one on locus 2, so we can rule them out as well, because they were not an exact match. Suspect 4 wasn't a complete match for either loci, so we can rule them out as well, meaning that suspect 1 was whose hair was at the crime scene. Now that you've figured out which of your dogs is the offender, you want to figure out which of your pets are related. Suspects 1 and 3 share one allele, suspects 1, 3, and 4 share another allele, and the victim and suspect 4 share one allele, which means you're kind of related to your cat. How cool is that? Suspects 1 and 2 share one allele on locus 2, and suspects 1, 2, and 3 share another group of alleles on locus 2. The only suspects, or your pets, that share alleles on both loci are suspects 1 and 3. This means that suspects 1 and 3 are most likely related. You find out that suspect 3 is actually the father of suspect 1. This means that suspect 1 inherited half of their alleles on each loci from suspect 3. So thanks for watching and stay on the lookout.